Yeah, so on Reddit somebody was talking about me teaching 250.
You should teach 250.
And they are sadly mistaken. I haven't taught 250 in like 5 years. Since my first year teaching, I taught my first 2 semesters. I haven't touched 250 since then. I have no intention on trying to get that class back. 250's brutal to teach. It's brutal for all. And that's a big reason why it's brutal to teach. The students are under so much stress and pressure. Because at that point, like, there are a lot of expectations. By the time you get into 250, like I have a lot of, I mean, I guess I'm talking to everybody here. I mean, I have a lot of expectations in 116, and you're pushed pretty hard in 116. While at 250 on day 1, there's that expectation that you're at that level that I expect you to be at the last day on that final exam. So that's day 1 at 250. 250 just keeps going from there. 220 as well. So the students who struggle through 116, they really start feeling the pressure, and they start putting that pressure on the professor. It's a brutal one to teach. It's a brutal one for everybody. But, okay, so today's a different kind of lecture, of course. This is our last live lecture. I probably won't even come back to campus till fall. So I'll be moving to Twitch. I made a post on Piazza, so if you haven't seen that, take a look at the Piazza post. I'll have more detailed information over spring break. I'll do some restructuring of the course and figure out what exactly we're going to do moving forward. Today it's somewhat business as usual, but I'll spend as much time as we need to talk about the changes. I have good news for everybody. There's no lecture question today, so don't worry about a lecture question. That might be my last round of applause this semester. Yeah, you can pog jump in chat. No, can't really clap anymore though. I don't know. So there's enough on everybody's plate. We don't need another lecture question today. There's no new content. I'm going to go through the examples that we saw last time and go through the debugger and actually see some of the changes. And I want to show some of the compiler optimizations that can happen when we're using this functional way of programming and immutable objects and all this stuff. We can see a few things that the compiler and that Scala can do behind the scenes to make our code more optimal that we wouldn't be able to take advantage of if we were using mutable states and things like that. So we'll talk about some content. If we get there, we'll probably get to some. Yeah, no lecture notes are posted today either. I don't have any new slides either. No new slides, no new lecture question. So there's nothing that's going to be posted on the course website.
Oh, it's live demo then.
What's that?
It's just live demo.
Yeah, just live demos today. But most of the time, I want to talk about what this looks like moving forward. So a lot of the course just isn't changed. I've already been leveraging a lot of technology. So lectures are business as usual. Actually, no, they're not business as usual. Let me clarify that. So lecture, I'll continue streaming on Twitch. So that'll be our main way of consuming lectures as they happen live. We'll continue to post the videos on YouTube if you want to consume the VOD. And you can watch the VODs on Twitch. If there's that time between the live stream and posting the video on YouTube, Mike's pretty quick with it. He gets them up pretty quick within hours. But if you don't want to wait for that, you always have the VOD on Twitch as well if you want to check those out. So all those are still going to apply. For those of you who have been coming to the live lectures and relying on that and ignoring the Twitch, just take some time, make an account if you have to, and get used to what's there, how to use the interface. The big reason to use Twitch, and this is especially important moving forward as we don't have the live lectures, is actually the Twitch chat. I want you to be able to ask questions during lecture just as though it were a live lecture. And I like the Twitch even when we do have live lecture because I get questions that might not have been asked if it were just a live lecture. Sometimes it's tough to raise your hand in front of 100 of your peers or 200 if everybody shows up and ask that question out loud and, what if it's a silly question, what if all this stuff. It's a lot easier to be behind the screen name and post on Twitch chat and be able to ask that question. It's one of the big reasons why I like Twitch. at least over any other streaming platform. There are other options that I could stream with. I like Twitch because we have that chat and we can have that interaction. So that'll be critically important moving forward. I'll have the Twitch chat so we can interact there. So you can ask questions during lecture. Lectures, there are opportunities here. To be honest, I'm kind of excited about this. It gets us thinking about different ways that we can deliver a course. I think one of the big advantages of this moving forward, this course, we'll have to do some innovating and change some things with it. But across campus, everybody has to innovate. Everybody has to put in place this streaming online-only architecture. And I think that's going to be really beneficial moving into the fall if we do all come back, when we eventually all come back, I think a lot of your courses, a lot of your instructors are going to have more technologies that they're going to leverage in those classrooms. So I'm kind of excited. It's a forcing function to get everybody to innovate and build out these tools. Even if it is just recording lectures and posting lectures, if that sticks for a lot of the courses, a lot of my colleagues keep doing that when we do go back to live lectures, I think that's going to be very beneficial. Question?
Yeah, are you guys going for the, after 23rd, right? On the 23rd, are you just going to do one live or 3 lives?
Yeah, so that's one of my things I want to talk about. So, I don't want to do 3. So this is part of my thing. So, with live content, we have a lot of restrictions in place just based on room sizes. I have to have 3 sections of 116 because we just can't all fit in one room. There's 600 students taking, that's not right. There are 390. It's a big difference. 600 was the total cap. That's the most we could have fit. 390 students taking 116. We just don't have a room that makes sense to be able to fit you all in. Actually, now they say that, I think next 20 is 400, but anyway, that's still even a lot of people to address live. But we don't have that restriction. Same with labs. Labs, we have a 25 student cap on each lab section. That cap goes away once we go online only. So I want to restructure the lecture times potentially. By default, I'll just stream 3 times a day still. But I don't want to do that. Not that that's not great and all. But what I'd rather do is stream for like a 3-hour block of time. Still do as much contact hours as I would have. But for the first hour, do what would be a typical lecture, what my lecture content would be. And then have 2 hours of more interaction, Q&A. Hey, can you show me an example of this? Hey, can you go over that example in more detail? And actually get more of that live interactive instruction that we don't really get in lectures now. Now I prepare one lecture and I deliver it 3 times. It's kind of wasteful, kind of a waste of all those meeting times, where if I could deliver that lecture to everybody once, which I can do now, and then make more use of that extra time instead of just doing the same thing 3 times. So I think there's an opportunity there to make the lecture times more effective if I can not be restricted to 1 p.m., 3 p.m., 4 p.m., if instead I could stream potentially like 1 to 4 or even 1 to 5, Monday, Wednesday, Friday, or Monday, Tuesday, Wednesday. You know, the whole schedule is blown up now. We have more flexibility to do different things. So I'll be in communication with you by default. If there's no better option, I'll just stream at the regular lecture times. But I'll keep in contact with everyone. It partly depends on what your other instructors are doing. If they're going to stick to their regular schedule and stream lectures at those times and expect you to be watching the stream at that time, then I'll stick to the schedule. But it looks like from behind the scenes, from what all the conversations are, it looks like a lot of my colleagues are going to be recording the videos, posting them online, and then not having that live stream, that live video stream. And then they'll have some live session where you can ask questions live and interact with your professor that way. But they're not going to have live streaming lectures at the lecture time, it seems like. But again, everything's up in the air, you know this. We've only had a day to really fully prepare and implement things so far. So a lot of this, a lot of their decisions and a lot of my decisions we're going to make over spring break, restructure our courses and figure out what the exact logistics are. But I might restructure lecture a little bit if I can get away with that and have more interaction during lectures.
How did
So the labs are still a big question mark for me. I want to have fewer lab times. That's one advantage that we can get out of this. What that looks like, we have a lot of ideas. My TAs have been coming up with a lot of ideas to address this, and I'm confident we'll figure out something. Just what the specific logistics are going to be is still up in the air. So we can still do interviews. We can just do interviews over the internet. We can still do the lab activities and just have fewer times and release the Google Doc or Google Form at a specific time and then expect it to be done 2 hours after that time. So not too much of that is affected. In lab, there wasn't too much that we took advantage of the fact that you were live, except the interview, and we can use web technologies for that. Another advantage of that is, I'm focusing on the positive, but I am really excited about the positives that we can get out of this, is say you get your lab activity, you knock it out in like 10, 20 minutes. Now you gotta just sit there and wait for your TA interview. We don't have that issue anymore because we can, or even if you're just on a roll, you're like, I got this, and your TA calls your name, now you gotta go do an interview. We don't have those issues anymore. We can schedule the interviews at a separate time. And you can sign up for a 10-minute slot with your TA, and then that's the time that you have the call and do the interview. So there are different things we can do, but I'm confident we'll find solutions. I just don't have specific decisions made yet as to what technologies we'll use for each thing. But we'll shop around and see what's going to work best for us. Labs are, as far as specifics, that's still one of the big question marks I had. I'll work with the TAs, we'll figure out the best solution, we'll test a few of them among ourselves, and we'll see which one we think is going to work best moving forward.
For office hours, we are going to also live.
Office hours, some of my TAs have already been testing with online office hours with some pretty good success. So Piazza is going to be the big, one of the big office hour spots. If you have to share your code. So the TAs, a lot of them are going to have times where they're going to be on Piazza. They'll say, I'll be on Piazza for this time, and then we can kind of have back and forth in the comments of your post. So make a private post with your issues, and then we can talk to you that way. We'll also have some more Twitch and even Discord office hours where we can handle more groups of students and group session things. I'll be doing some of my office hours on Twitch personally, and just having basically more lecture. Actually, that might just be part of my extended lecture plan, is having that more interaction with a group where somebody can say, wow, I really don't understand passing functions as arguments. And then I can go into examples and just kind of freestyle examples like that. I'll also do some office hours on Piazza. We still need something like Piazza, and Piazza is going to be our solution like that. So you can communicate sensitive material with us. So a private post on Piazza, that's going to be our main way of you saying, here's my code, or ask about your grade, anything like that. That's going to have to be on Piazza. Piazza's something called FERPA compliant, so anything we talk about that's specific to your record, your course enrollments, your grades, or anything, it's got to happen on some platform that's FERPA compliant, and we have to not share that with the rest of the class. So those are things we can't talk about on Twitch and Discord. So those things will have to be on either Piazza or email. I might have to respond to emails a lot faster during this time. But I'll definitely spend more time on those electronic platforms. Yeah, no lecture question, no slides today. Jesse plays Project Diva. Yeah, and maybe I'll use my channel to start streaming some games at some point. As long as I talk about computer science, right, that's fine. I mean, it'd be fine anyway. It's my private Twitch channel. I just happen to stream lectures on it also. I haven't streamed anything else on it before, but yeah.
We can use dynamic programming to solve our problems, like recursion problems.
Yes.
So recursion is a dynamic programming, right?
I didn't expect a content question. You caught me off guard here. So yeah, you could use dynamic programming as in your recursive solutions. Yeah. So recursion itself is not dynamic programming, but you can use recursion to do dynamic programming. For example, if you it's very distracting. Yeah, probably. There's no guarantee I'll be fully dressed when I'm streaming. There are other advantages. I don't have to comb my hair. It's going to be nice. So for example, when we did the Fibonacci sequence recursively, you would make two recursive calls, n minus 1, n minus 2, and add those together. That actually blows up the complexity of that call. It takes a long time to compute a Fibonacci number of any reasonable size. What you can do is throw dynamic programming at that and use what's called memoization. So whenever you call Fibonacci, you remember the result that was made. So if I say Fibonacci of 5 and compute the Fibonacci of 5, the fifth Fibonacci number, I store that in a data structure, and then whenever a recursive call is made, instead of just making the two recursive calls and adding them together, you first look up in that data structure. Did I already compute this? If I did, just return it without putting all those new frames on the stack and doing all that new computation. So if you want to use approaches like that, by all means, absolutely go for it. But it's not part of the expectation. I don't expect everybody to be throwing dynamic programming at this.
You can just make a list of words. So every time we find the Fibonacci sequence, we just add this to a list, and then so if we do the way you said that if I did it, so move forward and do other one. Check in the list if it's already done.
Yeah, if it's already done, just return it. Yeah. All right, so we talked about lecture, office hours, labs. I think those are the things I wanted to talk about. So does anybody have concerns, any other questions about this moving forward, about how this is going to work, what this is going to look like? Lana.
Someone in the Twitch chat asks, what do we do if we don't have a stable internet connection?
Oh, that is a good question. So what do you do if you don't have a stable internet connection? So that's something that's going to affect you in all of your courses. So my answer right now is to take that at the university level. There's going to have to be solutions for students like this. It's not going to be a course-by-course decision. I'll do what I can to help you. It'd be tough to watch the live streams, but you could still watch the VODs. But I can help you where I can, but I mean, it's just not going to be a single course answer. This question is being asked a lot. It's a question now. Nobody really has a good answer. There's no good plan of action for this yet. For students without reliable internet connections and also students without access to computers, I shouldn't say a lot, but a good number of students, more so outside of computer science, have to rely on the library machines to be able to get their work done. They rely on those to be able to take their courses. There has to be some university level solution for these questions. So I'll hold off on that and say I'll do what I can, but I expect a better university level decision to be able to help those students. Oh, Lana, why'd you delete that message? Oh, okay. Yeah, with the live interview. So that's the specific part, the live interview. We'll work something out. I mean, if that's a concern, definitely let us know as the time comes when we're talking those logistics. We'll figure something out. We'll not let that affect your grade. Yeah. Yeah, so at the time being, the campus will remain open. If you still want to come to campus, you have that option. No one will be required to come to campus, and I probably won't be on campus at all. So if you want to still come here to take advantage of the library machines, like I mentioned, that's still an option for you, at least as the time being. I haven't heard any talk about the university completely shutting down, but we are starting to put in contingency plans if it grows to that level as well. But as of now, the buses plan to keep running. The schools plan to stay open. And there'll be a lot of room. You'll be able to park for sure. You'll be able to get machines at the library. Yeah. The private study areas in the library. Everything will be wide open too. So. Yeah, all the lecture halls will be open if you want to come. Well, yeah, you'd have to get the passwords. I'm not going to share that. I don't want to get in trouble. But yeah, you'd have. Oh, actually, speaking of that, you all. This doesn't really come up these days much, but you should all have swipe access to Baldi 21. And that lab is going to be empty all the time now, too. So if you want to go take advantage of those machines, you should be able to swipe into the lab and go into that. What? Well, because it doesn't matter, usually. It usually doesn't matter because there's labs in there 8 a.m. to 10 p.m. every day. So unless you go there after 10. Only during their lab time? Oh, I would like that tested before I start. I don't know if anyone's going to take advantage of that anyway. If somebody does try to take advantage of that and you can't get in, let me know, send me an email, make Piazza posts, do what you got to do to get a hold of me. What? What?
Cables?
What about them? What about cables?
I just use it for my gaming.
I didn't hear anything. I should have just stuck with I didn't hear you the first time. If you go back home and don't come back until fall, I mean that's the recommended thing to do is to not come back. Plan on not being here the rest of the semester. It seems. I mean, I'm not going to give a definitive answer because just the way this was rolled out kind of took us by surprise a little bit. We knew something was coming, but I didn't expect things to cancel for the rest of the semester. And there's no guarantee that it's going to stay that way. I wouldn't be surprised if there's some announcement 5 weeks from now that says, hey, you have to come back for finals or something silly like that. I kind of hope not because I'd like it to say that we can all plan accordingly, but if everything opens back up and everything's fine in 5 weeks, I could see another tweet going out like, hey, surprise, you have to go back to school. I wouldn't. There's no indication that that's going to happen right now, and it seems like the experts are saying that the coronavirus is going to be an issue for that entire time period. So I don't foresee that happening, but at the same time, it wouldn't surprise me just the way this whole thing was handled. This is brand new territory for everybody, the whole world, all the leadership and everything. They're all figuring out how to handle such a situation. So nothing would really surprise me at this point. Yeah, thanks to Duo, we're all safe. Go Duo. All right, any other questions, concerns, comments about this situation moving forward? Okay, so yeah, just in quick summary, most of this course is business as usual. The lab logistics will be the big change, but the requirements will likely stay the same. Over the break, I'll look at the whole course as a whole and look at any small details that might have to be changed. I don't foresee too much that has to be changed, but if there is, I'll make those announcements over spring break. Any major announcements, I'll make over email. So over spring break, expect one big email that I'll send to the whole class saying, here's how we're adjusting for this new online-only mode. And then any smaller announcements, I'll be making those on Piazza. Piazza will start being our primary means of communication. That's where I'll make announcements to the class. With any major structural announcements, like the announcement that's going to tell everybody to check Piazza regularly, those type of announcements will be over email. All right, will you update the website as well? I mean, I do update the website multiple times a week. But yeah, any content that, I'll make announcements on Piazza. I'll still update the website with any relevant links. So some of the TAs will have Twitch office hours. I'll post the links to their Twitch channels on the course website, maybe on the photo roster next to their image or something. Posts like that I'll make, but I won't really make announcements over the course website. Maybe I'll have one big announcement that says check Piazza regularly at the top of the screen, but the website will be updated as normal. I was thinking about this. Am I going to use a face cam so you can see my smiling face? I would have to comb my hair if I did that, so I don't know. but I might. We'll see how things go. But since it's streaming only, I mean, I might. You have the emote to keep you company. It's not the same as the real thing, though. But all right, with that, let's get into some content here. So let's talk about computer science for a little bit here. So all the content for functional programming I got out there in those 5 days that we've been talking about functional programming. Anything that you're held accountable for, anything you need for the homework assignments, you have all that from the lecture content. You have all those concepts. So today, which has been the last day of each learning objective, each group of 6 lectures, the 6th one has always been examples, live coding, and things like that. Today's going to be no different. So let's take a look at these examples that we saw last time. I want to take a look at them, see how they work a little with a little more hands-on approach, and also I got too many things running through my head. And also break these a little bit. I want to make some changes to the code and see how the changes are affected. I read the mid-semester feedback, and one of the comments was, Jesse turns the lights down so low that I fall asleep during lecture, and I can't learn. So I don't know. I'll go a little higher on the lights. I have this, and then the next lower one is this. So I would ask you about it, and we talk about it a little more, but it really doesn't matter because this is the last time the lights are going to affect us. So when you're at home watching the stream, just keep your lights at whatever level you want. We don't have to have this conversation. But I'll put it one notch up. This is a little higher than I usually do. I usually go into sleep nap mode like this, but we'll put it up a little more because of that comment. Whoever you were, you did affect this lecture. I do read and listen to feedback. All right, so let's take a look at this example. So let's take a look at this example and see what's going on here. First, I just want to set a breakpoint right at the beginning. Let's run the debugger to make sure that we understand exactly what's supposed to happen with this. So once this fires up, we're going to create a new immutable counter with a value 10. That's going to call the constructor. It's going to create a variable named counter, and then run any lines of code that are outside of any of the methods. That's where we can have some of our initialization code. There are no lines outside the methods, so we hit the closing brace right away, the end of this code block. All the methods are defined, and we can return that new immutable object, that immutable counter. And we have an immutable counter at 588, and I'll use these ats a lot. I just want to reiterate, the ats don't really mean anything. We're only using these to tell if this is an object on the heap and what specific object it refers to. So our big question will be, are these at values the same for 2 different references? If they're the same, then those references refer to the same object on the heap. So just a reminder that these don't have any inherent meaning, but we will use them for that purpose to be able to tell if an object's on the heap and if 2 references refer to the same object. And we have counter equaling 10. We actually have this pin saying this is a final value. We can't change that. And we can move forward with the program. So let's do that. We're going to hit this line, update counter of 20, put a new frame on the stack. Check our base case. Our base case is false. N is 20 right here. N is not negative. So we're going to hit the else condition. N is a positive value. N is greater than 0. We're going to call counter.increase. That's going to add 1 to the counter. Not add 1 to the counter, but compute the counter plus 1. Create a new immutable counter with that value, 19. Call the constructor, call the code outside of the methods. That's going to return. And you notice we're in another stack frame, of course. That's going to return. And now we're going to call update counter of n minus 1, 19, with that counter increased by 1. So the next time I get this call, we have a new counter. We were 588. This is 589, so this is a different counter. This is the new one that we created. We got a reference to that. Its int value is 11. So now we're faced with the task, okay, we have a counter at 11, and we need to increase it 19 times. Next, we're going to have a counter at 12, and we're going to be asked to increase it at 18 times, so on and so forth, until we get down to that base case. And it just keeps running through how we would expect. And something I haven't mentioned before, I meant to mention it the last time, I had to click through again. When we're calling the constructor, that's actually another frame on the stack. The constructor is a method, just like any other method. This init, as it's called. So that frame goes on the stack while it's creating that new immutable counter. We're constructing this counter at 590. So this refers to that new counter that's being created. So whenever we use that keyword this, that's a reference to the calling object, in this case the brand new counter that's being created. So any questions on this part? We've seen that part before, right? So what I want to extract from that is each time we're making a recursive call, we're creating a new object on the heap. That's the part I want to talk about. That's a new reference each time we create a new object on the heap. And by the time we get to the end of this recursion, counter 2 is going to have some object on the heap. It's definitely different than the very first one. We get at 590. The numbers are random. Not random, but those numbers have no inherent meaning to us. But it is going to be a different number than any of the counters that were created during that recursive call. And each... Actually, no, I don't want to talk about that. Let's just do this. So given what we know about recursion, is this going to work? So with 20, we're making 20 recursive calls. We're creating 20 immutable counters on the heap. What if we do that with 1,000,000 counters?
Depending on memory.
Depending on what?
Memory.
Yeah, depending on memory.
How much memory the stack has.
How much memory the stack has? Or how much memory the heap has? These are all questions that we have. So do you expect the stack to have memory for 1,000,000 calls? Well, it worked. Will 1,000,000,000 work? So 1,000,000,000, it takes a little bit to think about this one, but still not that big of a deal. 1,000,000,000 recursive calls, 1,000,000,000 immutable counters being created. Still not that big of a deal. Oh, we could go, can we go that high? Oh, I'm overflowing an int at that point. 10 billion? No, we can't go that high. We can't overflow the int. But we can go pretty high on this. So why does this work? Why doesn't this break everything that we know about recursion? So let me set a breakpoint at our base case. Run this again. We'll hit this the first time when we hit 20. And what would we expect to see? What do we expect to see when we hit that base case? 20 frames on the stack, Jesse. Yeah, we'd expect to see 20 frames on the stack. We expect to see all those recursive calls, but when we take a look at our stack, we actually don't see that. We see one frame on the stack on top of our main frame. And we don't actually see all 20 frames on the stack. We don't see all billion frames on the stack. Those frames actually don't get put on the stack. This is one of the ways that the compiler can optimize for us, depending on the way that we structure our code. So here we have what's specifically called TailRecursion, where the recursive call is the last thing that's computed for our method call. So the recursion is the very last thing that's computed. So the compiler says, hey, since there's nothing else for this method to do except return the return value of the recursive call, instead of putting all these frames on the stack and saying, whatever this frame returns is going to be the return value of this frame, is going to be the return value of this frame, is going to be the return value of this frame, the compiler says, you know what, let's just not do that. If this call is already done with all of its computation, we're just going to destroy its stack frame and put just this call on the stack instead of preserving every stack frame all the way down the stack. So this stack frame is destroyed and replaced with that frame that it's calling, because all it's going to do is return whatever that frame returns. So why not skip the middleman and just put that frame on the stack? Now we can screw this up. If we say, if we have any computation that needs to be done after the recursive call, if we set this up so there's something that has to be done, I get this recursive call, I'm not actually doing anything, but the compiler's not that advanced. I'm not actually doing anything, but I'm going to store that in a variable and then return it. Now we run our debugger. And guess what we're going to get on that stack? Now Scala doesn't know, the compiler doesn't know that we're not actually doing anything important. It's going to put all of those frames on the stack, and we're going to get that full recursion. And now, if we make a recursive call with 1,000 or so, oh, I could have just ran it, I guess. Oh. I honestly did not expect that. There goes my punchline. Let's run this outside of the debugger. We don't need the debugger right now. But you saw 1,000 frames being put on the stack. Yeah, no sub button. That anyone who doesn't sub has to watch ads. I'm not doing that. So now I get my Stack Overflow at 5,000, and I was going to do this big thing. How high do you think I can go and not get a Stack Overflow? So even at 1,000, even with 1,000 recursive calls on the stack, that's actually going to be fine. Apparently, I knew I could go up to 500. I was prepared to go up to 500, but we actually get those return values. We do print counter to print counter, we get that 1,010, and then no, we can't put 1 billion frames on the stack. That would start overflowing my RAM, most likely, depending on how much each frame needs. But we can put 1,000 in this case. Those frames are lightweight enough that I can fit 1,000 of those frames on the stack without overflowing my stack. So when you're worried about, if you're worried about putting too many frames on the stack, computers are pretty resilient. They can handle quite a bit of, I don't want to say abuse, but a lot of work. So notice when I have this set up, if you look at this symbol right here, this is the symbol that says this is a recursive method. It's got this spiraling down. This is just something IntelliJ gives you to help you see what's going on. So I know this is a recursive method. If I delete this part, the symbol actually changes. That's the symbol for a TailRecursive method. If you see that symbol, you know you have some extra efficiency there, that you can get that tail recursion efficiency. And then even at 1 billion, notice that we did create 1 billion new counters on the heap. So this is still really inefficient. This isn't the best way to handle our business. But it does run, it doesn't overflow the stack. And the reason why we get away with having 1 billion of these objects on the heap, I don't remember if I mentioned this in this class to any great length at all. I think I went on a tangent in the other lectures. But those are going to get garbage collected. So as soon as we have an object on the heap that we don't have any reference to, we don't have its reference stored in a variable or in an instance variable or stored anywhere or a value, we don't have any way of accessing that object again, the JVM is going to notice that. It's going to say, you have no way of getting to this object anymore, and it's going to delete it. It's going to free up that memory. So what's happening when we have 1 billion recursive calls, we're putting 1 billion of these things in heap space, But they're getting cleaned up as we go, and that's part of what takes so long. We're going to create all these objects, and every once in a while the garbage collector is going to come through and say, whoa, you have all these objects with no reference to any of them. I'm going to destroy those for you. And then we put a whole bunch more on the heap, ask for a bunch more heap space, and lose all our references to those. The garbage collector is going to come through and delete all those. So we actually don't have much of a concern of overflowing our RAM, even though we're overflowing an int here, so I can't give it a bigger value. Actually, I can just do it. No, I don't want to wait that long, though. But it will run. It won't run out of heap space. So even though I have 1 billion here, and in each one of those stores, at least an int plus some overhead. An int's going to be 5 bytes, so I have, or 8 bytes. Oh, my goodness, I can't think. 4 bytes. So I have at least 4 gigabytes of memory that this is using. And we're not going to see all of that used up in my RAM, which actually I'm curious now. We will be able to see how much RAM it does start taking up. We should see a process named Java jump up to the top of my list here during the execution of this. Oh boy, I hope we do. Don't make me look bad, computer. No. I'm not losing that easy. Oh, jeez. Is this worth it? There it is. There it is. Java taking up a gig. Sitting there at 1.35 gigs though. That must. So depending on how the garbage collector works, maybe 1.35, maybe that's a magic number for the garbage collector to say, hey, let me go in here and look. I don't know how they work. You'd have to ask Dr. Hertz. Oh wow, it did all those already. It already finished. You have to ask Dr. Hertz. He's an expert on garbage collection. That sounds like a joke. That's not actually a joke. Like his PhD work was in the JVM garbage collection. Anyway, if you want to know more, ask him. He's got all kinds of info for you. But for our purposes, let's move on to the next example and talk about strings. I'm sure that came off wrong. That's not how I meant it. I didn't mean that to be a joke. But let's talk about this string example. So the string, we were just moving strings around, storing some of them in references. Some of them we were just leaving on the ground. So let's step through this thing and talk about what's going on here. Yeah, when you write TailRecursion, when you write a TailRecursive method, as long as it's set up with TailRecursion, Scala's going to see that and then just use TailRecursion. There's also an annotation. You can annotate your method as being TailRecursive with the @tailrec. If you have that annotation on there, it will give you an error if you don't have TailRecursion. So if you intend to write a TailRecursive method, use that annotation right above your method. I might as well actually do it since I'm already talking about it. Use your annotation tailrec, and that's going to tell Scala, I have to import it. And that's going to tell Scala, I fully intend this to be TailRecursive. Now, if I don't have TailRecursion, instead of me having to look at this symbol or look through my code and verify that I'm TailRecursive, what this tailrec does is enforces that this has to be TailRecursive, and it gives me this nice error. It's going to say, hey, you told me this is going to be TailRecursive, but your recursive call is not in the TailRecursive position. It's not the last thing that happens in your method. So then it's just a big flag that says, hey, you told me this thing and then you didn't do it. Maybe you should look into that. So the TailRec can help with that. It can also help other developers. If you have somebody else on your team that's going to be editing this method and you have the TailRec there, it makes it very clear to them that this should be a TailRecursive method. And then if they break the tail recursion, they're going to get that error and they're going to be able to see. And hopefully they don't just say, well, I can just delete this and it gets rid of my error. Hopefully they're not someone doing that or using autocorrect and autofix. If it's something like that on your team, you got more problems anyway. But the TailRec is a good thing to use if you want that to be tail recursive. It can help you make sure that you actually are tail recursive. All right, so let's step through this string example. We create a string, CC116. It's on the stack, or on the heap at 587. Start stepping through. We go into a method call. We compute this CC115. But we don't do anything with it. So the state of our stack, completely unchanged. We have an extra object on the heap, but we don't do anything with it, so it doesn't really affect us at all. We're going to call amplify. That is going to give us a return value. We're going to store it in a variable. I don't know why I'm expanding the strings. There's nothing to see in there. So we have these two strings on the heap, and we have references to those strings on the stack. So we can refer to those strings, we can access those, CC 116 and 250. We're going to create another string. CC 116 is fun, at 593. These are all things we saw in the slides, and I assume you can all follow through those pretty well. What I want to talk about is these next two lines that we didn't see yesterday. I want to talk about why I have such silly lines. Of course, the program doesn't do anything, but just to show you what these are going to do. So I'm going to create a value, another string, just some very creative name, and assign it the value CSE 116. When I do this, this should create a new string on the heap and return a reference to that new string. That's what we understand with strings, right? But when I call that line, CSE 116, I have in two different variables, and if we look at the references, they're both at 587. So when I had that second CSE 116 string that I'm creating, it actually doesn't put another object on the heap. It just gives me a reference to the object on the heap that already has that exact value that I'm looking for. And this is something that we can do with immutability. Without immutability, the JVM cannot give us this kind of optimization. This is just something that it wouldn't be able to do. But with immutable objects, it says, hey, you want another string with the same exact value? I already have one of those. And what's more, I know it will never change because it's immutable. Since I know that's never going to change, I can just give you a reference with that without having to worry about anything. Let's give you a reference to the string I already have with that value. No need to worry. Everything's going to be fine because I know that's never going to change. So why not do that? I'm also going to create a list. And we take a look at the references here. That at 116 in there twice. Again, it's still at that 116. It's still in there as 587. So these are all the same string. I have references to the same string 4 different times in my program. But this isn't always going to be the way it's optimized. I have the CSE 250 and CSE 116 is fun. These strings also exist in my program. We have them right here, but we don't get these references to these strings. So this is a case where the compiler, the JVM, it's going to optimize where it can see good ways to optimize, but it doesn't always optimize exactly the way it could every time because of the way we built these strings in this case. So we used replace to create that 250. If we just return CSE 150, let me move my breakpoint so I don't have to click through. Then we will get CSE 250 reusing that string that we already created. So just creative ways that the 625, 625. So there's creative ways that the compiler and the JVM can work together to optimize our code, but it can only do this if it knows we're using an immutable object, which strings, in this case, it knows they're immutable, and it has a lot of optimizations with strings. And let's just quickly, I want to show this, the list example, very, very quick. Is going to be, we'll talk about linked lists a lot when we, after break, but just as a foreshadow, a little prelude, I'm going to have this list containing just 2 created. Oh, come on, debugger. Work with me, I'm out of time already. So I have this list that only holds the value 2, and it's at 959. If I go to the next iteration, the next recursion here, I have this new list, 1107, and if I get the tail of that list, which is the list containing all the elements except the first element, if I pull out tail, this next is that exact same list at 959 that we had in the first step of the recursion. This is the same exact list that we had in the base case. So if you notice, if you were watching very carefully on Wednesday, I never talked about garbage collection when we were talking about the lists, because those lists did not get garbage collected. When we created a new list, we actually just created one element and then had it point to the other list. So we actually kept all those lists on the heap. We just reused them each time we created a new list. So we actually didn't copy all of the elements over. We just created one new element and said, refer to the rest of the list. It's right here. And we can see that in the debugger. We can see how it's optimizing like that. And this specifically works if we're using prepend. Append, we don't get the same efficiency, and that's something we'll talk about for an extended period of time after the break. So with that, good luck, stay safe out there, and we'll see you online.